Good afternoon, everybody, and thank you for joining ESOA's showcase session this year. At ESOA, we like to show all the good work our members do, and you can see who they are on this slide. But we also work closely with many partner organizations, such as the European Space Agency, and today we are going to be co-hosting our showcase session together with them. The essential role of satellite to enable diverse 5G use cases is becoming increasingly clear, but there is plenty of technical work behind, and ESA is very active in making a lot of it happen. Today, the European Space Agency colleagues are going to talk to us about 5G new radio for non-terrestrial systems in FR1 and FR2 spectrum. So, I'd like to start by introducing my colleagues to you. We have Frank Zeppenfeld from the European Space Agency and his colleagues Daniel Arapoglu and Stefano Cioni. Welcome to you all, and thanks so much for co-hosting this with me. So without further ado, I'm going to hand over to you, and I would invite everybody watching to please post comments and questions in the session chat. We will get to them after the presentation. Enjoy the presentation. Thank you.
Thank you very much, Arti, for the introduction. We're very happy that we have the opportunity to sketch a bit the activities that ESA is undertaking in the area of 5G and satellite. Let us introduce ourselves a little bit. We are a group of, let's say, more than 100 persons working on satellite communications spread over the UK, in Harwell near Oxford, and in Noordwijk in Netherlands, close to Amsterdam. And basically our job is to keep European and Canadian industry competitive in the area of satellite communications in the whole satellite world market. And we identify new trends, we initiate new projects, and we also technically manage these projects. Next slide, please. We have a number of countries that are actually supporting us and let's say the budgets we get from all those countries, and together with these industries from those countries, we do common projects, and they could be in the ground segment, they could be in the space segment. That includes also in orbit validation of new concepts, so basically launching, validating satellites, and regularly we issue tenders for more longer term developments, and we co-finance quite a number of more near-term developments which are proposed by industry. And we have quite a large amount of technical support that with which we help the projects in terms of patents, test facilities, and also some regulatory advice and supporting the technical management of those projects. Next slide, please. Now, back to the 5G topic itself. A few years ago, there was a unique opportunity when the 5G envelope was discussed to introduce satellite. And as you maybe know, satellite, the so-called non-terrestrial networks, NTN, they are now an integral part of the 3GPP architecture. So satellite and terrestrial will be integrated networks. And that will be specified for the first case that we will see in the so-called release 17, which will complete next year. We have initiated a large work plan in one of our 5G strategic lines in ESA that is supporting the development of critical developments, and it's also supporting test and validation of prototypes. 5G new radio, the terrestrial standard, is going to be adapted as we speak in the various standardization group of 3GPP, and that will result in the so-called 5G new radio non-terrestrial network. Next slide, please. We are not doing this alone. We have reached out to many in the satellite communications industry, operators, equipment providers, application providers. And we are currently working with a large group of people in the satellite industry to prepare and support them with contributions to the 3GPP standardization group. We have a larger activity called ALEX. Maybe that is something you will hear about in the future, where we support industry financially, but also with technical discussions, preparing common contributions to 3GPP. And as such, we have a common voice of the satellite industry towards further standardization of 3GPP. Next slide, please. To get a bit into detail regarding the satellites and the 5G networks, we will see a number of different architectures where the satellite could directly talk a so-called UE in 3GPP speak, so an end user terminal, or that could maybe be used indirectly, but basically one would be using the 5G air interface from the satellite to the user. And what you see in the left side, the G node B, the base station, will then be located at the gateway, or is actually the gateway. And then we will link to the core network, the purple box that you see. So at the left side, you see here the variants that you can have direct access to the user. On the right side, we see an architecture which we call the satellite backhaul. So here, the base station is located remotely, and the end user devices are locally linked to the G node B. So the 5G air interface is not going over the satellite, but it's just the backhaul interface between the G node B and the core network, or let's say IP-based. These two variants, we have development started to make sure that the future satellite equipment, but maybe also the satellites themselves, can handle those architectures. And as such, we would be able to integrate seamlessly with the terrestrial networks. Next slide, please. We also know that there will be legacy networks which are not using any 3GPP standards. Now, within the standardization of the 3GPP core network, there is also a feature that allows specifically the integration of non-3GPP networks. So that could be legacy networks, that could be DVB-RCET networks, which are not based on 3GPP, or any other proprietary gateway, how to integrate these systems seamlessly with the 5G core network. The advantages of that would be that one could use in the backend the same billing mechanisms, the same OSS, the same business support systems. All that would be seamless for the operator, whether he's working with a terrestrial network or maybe a proprietary satellite network. Next slide, please. To sketch a bit the developments we are currently undertaking, one of the most important things, if we talk about 5G, we need a protocol stack. Otherwise, we will not be able to do any direct access to end user devices. We have been starting development with European industry. We'll tell you a bit more about that because we've been testing that also recently over satellite. We need, as given in the previous slide, we need to be able that we can also integrate non-3GPP networks. We will need end user devices that can do both terrestrial and satellite frequency bands. Furthermore, there is an architecture that we didn't touch upon, which is a bit more forward-looking, where we'll have a complete base station in space. We are working on that already for narrowband IoT, to have that in space. And soon you will see from our side also a tender appearing to build and demonstrate a 5G base station in space. Furthermore, we are starting some projects, likely with more smaller satellites, to demonstrate 5G directly to handheld devices in the lower frequency bands. The next slide, please. One of the recent results, we'll come to that, that is the topology that you see here as completed. You see here 4 different demonstrations that we are planning to do, and one we recently completed. We would like to demonstrate 5G new radio pre-standard, because the standard will likely only be completed in summer next year, but there is sufficient meat already to demonstrate a few essential things. So we demonstrated this new air interface over Ku band in geostationary, with the geostationary satellites. We will soon embark on a trial to do the same in Ka band. And as you know, Ka band will suffer probably a bit more from the adaptive coding and modulation we will use there to suffer maybe from attenuation and fading. We are also intending to do a 5G new radio trial over LEO Ka band, which will, of course, have its own difficulties in Doppler compensations, etc. And we still, that's a bit more longer term, hope to do a trial with maybe existing S or L band satellites in GEO to demonstrate 5G straight to the handset. Maybe a bit more detail in next slide. This is a trial that we did recently with the people you see here mentioned at the right side, the Munich Center for Space Communication, which is linked to the University of the Bundeswehr in Germany, Eurescom, Fraunhofer, and a number of projects below that, which have all delivered contributions. And this led to the world's first demonstration of 5G new radio, specifically adapted for a non-terrestrial network. You can see with the large dishes here, this is still a trial, but you can see here in the plots, let's say the first QPSK modulated the shared uplink channel and the shared downlink channel, which are traveling over the air. Now, this is the work we will try, or we are going to continue in the coming year for both the GEO case and the LEO case. All this could not happen with, let's say, proper standardization support. My colleague Stefano Cioni will now say a few words more about what is really happening in the area of standardization, both more in the narrowband area and also in the broadband area, the 5G new radio. Stefano, please.
Thank you, Frank, and of course, thank you also for Arti and the ESOA for inviting us today for this speech. So, yeah, I will touch in the next couple of minutes a bit more information related to the standardization process. So, as also said by Frank, just last week, NTN, so non-terrestrial network, is also covering another use case, very important also for satellite communication, that is related to the IoT, Internet of Things market, and in particular has been approved by the RAN group that a work item, so as for new radio, so for the broadband use case, there will be also aspect of enabling narrowband IoT and LTM over satellite in order to enlarge the portfolio of services offered also by the satellite component. This as also is a baseline for NR NTN. This will be an enabler to have, let's say, a worldwide standard that will embrace either terrestrial and satellite network to deliver IoT type of services. And probably, as you know, you have seen also a press release a couple of months ago where there was also an initial trial made by Inmarsat and MediaTek, and that's also other, I think many after that demonstrate already pre-standardization demonstration in GEO and LEO constellation. Next slide, please. So just a quick recap and additional information also now going into more detail on the spectrum related topics. So first of all, let's say for if it is not, for whom is not familiar with the definition, I just recall frequency range 1 definition is all the frequencies below 7.25 gigahertz, and frequency range 2, or the so-called millimeter wave, that is the innovative part in the 5G technology system, is all frequencies above 24 gigahertz. Just and also in information, just to avoid the misinterpretation about, let's say, frequency spectrum regulation. So there is no, let's say, endorsement. There is no commitment, of course, from 3GPP to define or to make available additional spectrum. The sense that this, of course, as you know, this is a duty of regulatory bodies all over the world, ITU or regional. What 3GPP is working on, of course, is once frequencies and spectrum is available for different technology, satellite or terrestrial, will identify and double check the conformance of the RF equipment on both sides, user equipment and the base station. But it's not a regulatory body, just to be clear. 3GPP is not a regulatory body. In terms of what is already available, at least in the candidate bands where satellite can initiate demonstration trials and, of course, also making system deployment, are just reported here. So we have S-band, we have band 65, that is MSS band full frequency duplex, around 2 gigahertz, let's say, quite, let's say, used also in the past for mobile broadcast application. And then we have S-band in TDD mode in time duplexing. The number is band 53. And last but not least, there is also the spectrum in L-band, and the number is 24. Next slide, please. So some other important information, just a quick snapshot to align all ourselves on some aspect related to satellite 5G and spectrum. Again, in accordance with ITU regulation, let's say in frequency range 1, so below 7 gigahertz, terrestrial network and non-terrestrial network cannot offer services in the same band, in the same coverage. So we always talk about adjacent band compatibility, and this is just important to remind. Then as Iridium, that is at the moment the particular case of adopting a time division duplexing, is important to remember that satellite band operate in frequency duplexing mode, and of course this has primarily implication for the so-called millimeter wave, so in frequency range 2, where so far 5G terrestrial network specification and 5G network deployment are only looking at TDD type of technology. And last but not least, is important to remember that most likely the release 17, that as Frank said, will be the first time ever we will have a satellite component in the terrestrial specification, will cover only frequency range 1 type of spectrum, so below 7 gigahertz. But luckily, we have also very good progress last week in this respect. And in the next slide, please, I want to capture that has been also paved the way forward for also the frequency range 2. And of course, if you want more information with the detailed text, I put in this slide the reference document approved just Friday. So we're talking about very fresh baked news. And in particular, the first agreement is an endorsement from the 3GPP plenary group that Ka band, or at least a portion of the Ka band, is a candidate example for NTN-NR type of service. And we look at in frequency spectrum above 10 gigahertz for both geo and non-geo type of satellite. And also important in the second agreement is that all these technical aspects that are matters of the round 4 working group, round 4 we look at in more detail, as I said, the technical aspect related to the FDD, so frequency duplexing, frequency division duplexing for millimeter wave. That is a new type of technology for the terrestrial 5G network. And also the baseline is that in frequency range 2, the terminal on the satellite side will be based on VSAT and eSIM. So in terms of regulation, in order to be compliant with MSS and FSS type of services available in that range of spectrum. And as a note, let's say the Ka band, so the portion, the last, let's say 2.5 gigahertz, for whom who is aware, is used as a priority base because this is a common allocation all over all ITU region. Next slide, please. So in terms of, let's say, summary related to ESA interest in 5G and satellite, of course, cooperation, we would like to remind that we are supporting our, let's say, primary role is to support and promote for our European and Canadian industry R&D development in order to sustain and to enable entering in this new market of 5G and satellite. Then, as also mentioned clearly by Frank, there is the need also to have and to demonstrate pre-standard building blocks of the overall release 17, and in particular open source type of tool like was shown before with open air interface could be a way to enable preliminary R&D development for early demonstration of with at the end also live trial and live experimental campaign using satellite. And then, of course, since this is the latest news, we are also looking at either new radio over NTN or IoT, and in particular, some development on narrowband IoT with also the E-Node-B, so the 4G base station in space will be the next step we are looking at. As also mentioned before, of course, all type of 5G tests, trials, and experimentation are very welcome for us, and we are willing to support our member state industry to do so. And of course, Release 17, just as a final remark, is the first one, but we don't want that will be also the last one. So we have also now to be ready and to prepare the fact that evolution, enhancement, and also enrichment of the type of services in 3GPP could be necessary also for the satellite industry. So we are also looking forward to starting the 3GPP release 18 that will be discussed in the next 6 months, and the kickoff probably, if you know, will be from Q1 2022. Thank you very much.
Excellent. Thank you so much for that presentation, Frank and Stefano. Welcoming all of my ESA colleagues back onto the stage. Just a reminder, if anybody has any questions, please post them in the chat. But let me start with a few of my own. Who is implementing 5G satellite right now, and which spectrum will 5G over satellite use? I don't know who wants to take that.
Maybe I'll take one first part of the question. At the moment, we see a number of people in European industry doing that. It must be said sometimes by triggered also by ESA funding, because we are at early stages, and that is also the whole idea, let's say, to use this R&D financing to get the first things rolling. So we see a lot of people active in the German and French industrial ecosystem, working on the protocol stacks. We know there are some people in China developing probably made proprietary stacks. but that is at the moment, you could say, the industrial base. Maybe the spectrum I leave to Stefano.
Yeah, as I mentioned, in terms of spectrum, NTN will cover the full range, let's say frequency range 1 and frequency range 2. So in terms of early development or pre-standard demonstration, as ESA, we are open to both. So as Frank mentioned, we already did some trial either in KU, we are going to do in KA, we are planning to do in S-band. So from our perspective, let's say, both sides of, let's say, of this frequency range are good. In terms of standard, as I said, of course, the priority for 3GPP in release 17 will be only frequency range 1, so below 6 gigahertz, and in particular LS band. But nothing is preventing that, of course, going on release 18 and even parallel development of releases will cover, as I said, the full spectrum range.
Got it. Okay. And we know that there is a lot of interest in direct access and a lot of questions about when the chipsets supporting 5G new radio NTN or 5G NB-IoT-NTN might be available. And in fact, I see a question on the chat from Chris Nickerson from Analysis Mason. How far off is new radio NTN satellite direct to smartphone as a mass market proposition? How far off is the technology? The pictures showed the user equipment as huge dishes, very different to the antenna on a standard smartphone. And he has two parts to his questions. What is the new radio NTN 3GPP timeline? Release 17 to be completed end of this year. Three parts to the question. How long will it take for this functionality to get into the device ecosystem? And I think this is really something that people are very eager to hear about.
Yeah, let me try to give an initial answer, and then, of course, I leave also the floor to my colleagues. So in terms of standardization, just to be practical, release 17, as we mentioned, is going to be completed end of this year, or let's say first quarter of 2022. So once, I don't have, of course, a crystal ball and to predict how many months we should wait afterwards that some chipset manufacturer will implement release 17. This is also related to some dynamics in the market, but let's say probably to be realistic, other 8-10 months. So probably we will need from now other 2 years to have chipset ready and to start to do some real pre-commercialization demonstration or pre-development, let's say, with satellite and terrestrial integration. Of course, the question related to handheld, again, is related to the same fact. We are aiming not to put a dish in our smartphone. So, of course, also in frequency range 1, the target will be to have a smartphone with the capability, with existing space asset or new space asset, to make this link available to our smartphone. And I think the last part was related, yes, so exactly, no, the antenna. So I think I cover at least from the standard point of view. I don't know if Frank or somebody want to complement.
Yeah, maybe Stefano, together with your help, we can, on the first part, which is interesting, because in ESA, we've been looking also at the possibility, which is the ultimate dream, to connect directly to an existing commercial smartphone from the satellite. But there are also some technical challenges to that, even beyond the link budget from the waveform point of view. There are issues that you guys in 3GPP have been studying, like the timing advance, synchronization issues, the fact that maybe if the coverage comes from a LEO, you have a moving cell rather than a fixed cell. So there are also waveform dependent issues, and then there are also plain link budget issues, if you like, that we are also considering, either with industrial contracts and studies or internally, that may be overcome with new technologies, especially in the space segment, I would say.
Okay. Frank, you want to come in on that, or should I move to the next question?
No, I think it's sufficiently covered. Very nice. Thanks. Yeah.
Great. Okay. Then, another question which is often asked is about whether we can share spectrum. So what can you say about whether spectrum sharing between 5G NTN, 5G terrestrial networks, how will that work?
Yeah, that is a question where, yeah, sorry, I had here an audio drop. That question comes up quite often. At the moment, and I'm sure that Stefano can add a few words to that, there are detailed discussions ongoing how to, let's say, practically share, because the actual sharing between frequencies, terrestrial and satellites, that is something for the regulator. That is independent of the air interface when it comes to this elementary sharing. But now, when we're using the 5G air interface, there might be some practical issues related to distances of base stations, power from base stations, etc. That is a topic actually which has been discussed quite a lot last week in the RAN group. And I think Stefano can add a few words to that too.
Yeah, exactly. So about, let's say, sharing could be, let's say, at the same time, a nice word, but also a dangerous word. So actually, in terms of a regulation aspect, as I said, the 3GPP has not any power to change or to steer a regulation or a spectrum, let's say, matters. The work that will be done in 3GPP for enable this type of sharing, of course, is to look at the current regulation and to enable for a terminal to listen when the terrestrial coverage is present, or to change to the satellite air interface, or to satellite, let's say, type of network to keep continuity in type of services and communication link. So in this respect, the sharing is limited to the fact 3GPP is want to share the technology. Then sharing the spectrum, I think, as also Frank said, is something that we need help and coordination among the regulatory bodies and all regional or country type of rules.
Okay, great. And can you say something about what the main technical challenges are for the 5G new radio waveform to work over satellite?
Yeah, I think my colleague Daniel mentioned something before in the previous answer. So essentially, you can imagine, so we are moving from a terrestrial waveform that has been designed with certain constraint, with certain, let's say, requirement to satellite. And we have also to distinguish between geo and non-geo type of constellation. So the first things that I think come to our mind, talk about the geo, of course, we don't have mobility problem because the satellite is fixed. It's only, let's say, a big mirror quite far in space. So this is introduce essentially delays in terms of waveform. So from the pure physical layer and type of waveform, there is no big issue. Let's say is an FDM signal. The only things that mainly related, of course, is to the initial synchronization with longer delay in the access to the network, and of course compensate for the virus timers in the protocol. But mobility will become for sure an issue for non-geo satellite. So maintaining the maintenance of the alignment between uplink and downlink, so the so-called timing advance, is more and more challenging. Frequency compensation or pre-compensation due to the Doppler is another important modification that is mandatory for the 5G new radio. And then all the movement, and all the modification related to mobility in terms of handover. So when we are changing from a beam to another, when we are changing from a satellite to another, or the feeder link handover. So all these aspects that are peculiar for satellite and not for terrestrial network will become the first list of features that our industry and our 3GPP delegates are looking at in Release 17 and beyond.
But maybe, Stefano, we can add a positive note that since 5G new radio is a multi-carrier waveform, which is not so typical when we look at the single carrier based DVB-S2 type of waveforms we typically use in broadband SATCOM. In that respect, I think we agree that there are no limitations. I mean, the multi-carrier maybe has a slight impact over the nonlinear channel of the amplifier of the satellite, but overall this seems to be working well, right?
Yeah, no, exactly. All these challenges I mentioned, of course, are not big barrier or big walls. Actually, we are working on that, and I think already pre-demonstration and trials that we did demonstrate that is feasible. Yes.
Great. Okay. We have another question that's come in. I don't know if you can comment on this. What about EMF from 5G NTN systems? So the electromagnetic radiation from 5G NTN systems.
If I can, let's say personally, being compatible. Actually, 5G is not changing what are the already regulated type of service via satellite or for terrestrial networks. So, at least in 3GPP, this is not tackled because actually this is left to somebody else. So we are just following the instruction given by regulatory bodies.
Indeed. And I mean, we have to remember that the signals come from outer space. They don't come from base stations, which are next door. So it's really a wholly different subject that we're talking about. Okay, one last question from me. 3GPP recently moved the NB-IoT work to a normative work item, which means that we can expect core specs in, I think, March 22. Can you say something about the relation between 5G new radio and NB-IoT over satellite?
Yeah, so the relation is that, of course, from the standardization point of view, all companies, all industries and stakeholders are willing to exploit as much as possible cross synergies. So let's say not to do a modification twice or try to find as much as possible solutions that cover the NR, so the 5G waveform and narrowband IoT. So we know that essentially they are very close to each other in terms of technology. So from this point of view, this is perfect, and modification will be more or less aligned. The main difference for the moment, at least for the architecture, as mentioned by Frank, is that narrowband IoT or LTM is a 4G type of technology that is connected to the 4G EPC, so the core network, and this will be the baseline for narrowband IoT, of course, while the NR is connected to a different type of core network. This, of course, at the beginning will be two separate paths. They will actually also good because it means that satellite will be enabled to talk with both types of technology. And at the moment, even narrowband IoT will be able to talk with both in terrestrial network. For satellite, initially, we will have two different types of core network connected to the sensor, or let's say to the device. But this is a minor problem as long as I said, from the technology point of view, with this last agreement last week, also narrowband IoT will be part of release 17, and technology with essential feature will be available in 1 year plus the months needed for the chips manufacturer to take in hardware this modification.
Okay, great. We don't have long left, but let me ask a basic question. Right now, we see a lot of interest from terrestrial operators, terrestrial companies in satellite, whether it's investments from mobile operators, the most recent one being last week from 4IG in Hungary into Amos Spacecom, or whether it's companies like Amazon with their Project Kuiper. What are the practical advantages of integrating satellite and terrestrial networks? Why is all of this happening? What are companies seeing?
Yeah, I would say let's take it from the user point first. it would be very nice if you would have a handset that is, as every user now expects to have roaming between one network and the other network. If satellite would be part of those networks, the user could be supported also in areas where there is no connectivity, only in this case satellite, and he would not notice any difference. To enable such a seamless integration from a user perspective, you need standards. And this standard that is now being built, the new radio non-terrestrial, together with the terrestrial, that would, from the user perspective, allow this seamless connectivity. If you now take it from the operator side, then it would, of course, be very beneficial if you would not have all these proprietary network management systems for the satellite, for the terrestrial network, and maybe for some legacy system. This could all be integrated in a 5G core network. There are many projects, for example, integrating 5G into current fiber systems, or other maybe a bit exotic systems which have not followed the 3GPP standard. So that makes it, from the operator point, quite attractive. Then from, you could say, equipment size, it would, for the satellite community, of course, quite nice to benefit from all the R&D and equipment development that is ongoing in the terrestrial world. There is a lot of things that can be reused, maybe in different frequency bands, both at the user and the station. So that I see as very, practical advantages of using the 5G air interface.
Great. Listen, fast forward 10 years. What does the world look like in the last 2 minutes? Give me your thoughts. What does the telecoms ecosystem look like? Where are we with all of this? Yeah,
I would say, because it's interesting to see with the narrowband IoT part, there is a relation, as Stefano was explaining, but you see that the narrowband IoT seems currently very much the domain of a few small, let's say, new space type of companies. So I forecast that there will be a few of those new space companies offering narrowband IoT services over satellite. On the broadband, no, that is for me too much a crystal ball.
Excellent. We have 1 minute left. Stefano, Daniel, do you want to come in on that last question?
Maybe on the broadband, I think higher frequency bands, QV, W, and maybe even optical communications are coming, at least for the space networks.
Excellent. Stefano, last one?
Last word will be, for me, we will not talk about any more of satellite and terrestrial. For me, let's say in 10 years from now, we will talk about a big network connecting everybody, everything in a very seamless. We will not talk about integration. It will be really unification, I would say. We will have a unified network all over the world.
Perfect. And hopefully the user will really see huge benefits from all of this convergence and progression. So on that note, I'm going to thank you all so much for having co-hosted this workshop with me. Thanks to Forum Europe for having given ESOA the opportunity. And thanks for everybody who's been listening. Thanks very much.
Thank you.
Thank you. Thank you, everybody.
Thank you.